Welcome to June 13th LeetCode Challenge, Palindrome Pairs. Given a list of unique words, return all the pairs of distinct indices I, J in the given list, so that the concatenation of the two words, worded I and worded J, is a palindrome. So let's go through our first example here. So let's see, we have, alright, let's go. We have a word list here. We have index 0, 1, 2, 3, 4. And then we have our output, which is telling you 0, and index 1 are palindrome pairs. So what that means is that if we concatenate index 0 with index 1, then we get a palindrome pair, as for example we get right here. Right? It doesn't have to be in the correct order, but we have concatenate index 0 and index 1, and we have itself is a palindrome pair. And we have this example here, 1, 0. So if we concatenate word index 1 right here, which is db, this one right here, and then we concatenate with 0, we also get palindrome pair. Let's go for this example over here. We get 3, 2. So it's telling you we concatenate index 3, which is S, and index 2, we also get palindrome pair, which is right here. And then 2, 4, we concatenate the index 2 position in the list, which is 0, 1, 2, so LLS, with index 4, we get this palindrome right here. So notice how the palindromes are part of the list, that we concatenate I with J in specific orders. Either this goes first or this goes first. Then we should be able to make a palindrome pair out of it. So so notice how each of them have something called a prefix, so words in the beginning, right? And we have something called a suffix. These are things at the end. And all the prefix and suffix come from the word list. So an approach to this would be to, since we know that our word length itself is under 300, why don't we go about generating all the possible candidates for the palindrome pairs? We're going to be able to generate this list, and then from this list, we're going to see what of these possible generate all the palindromes possible from these, and we're going to see which ones will make a palindrome out of it, right? And will fit our criteria. So that's how we're going to approach this question. And we're going to use this word length to our advantage, right? Because it's only under 300, while the length of the actual list itself is quite long, so it's 5,000. Alright, let's go about doing this. So the first thing I think would be useful to be storing our list of palindromes would be using a dictionary. So we want to be able to store our information in a dictionary, because it's we want to be able to not only decrease the time complexity, but also it's nice to have it ordered in a way where we actually retrieve it by index. Another way, then next thing we're going to do is we want to so we know that we're looking for prefixes and suffixes, but we also know that palindromes work by having it in the order that you see it in, but also the word in reverse as well have to be able to make a palindrome out of it. So let's create something to be able to look for all the reverse words within your words list. So we're going to say for I word in enumerate word. So we're going to enumerate it in order to make a pairing out of it in words. What we're going to do is that we're going to store the information into our dictionary, a dictionary I should say. So word at, and it's going to be a reverse dictionary, so what we're going to do is we're going to do that, equals index I. Alright, so we have that going on now. We have our word list in reverse order in enumerated into a reverse word in a dictionary, so it's going to be easy to grab here. So notice right here, we're enumerating through words using a for loop. So far we have, if we were to call this n and this m, it will be, we're looping through it n times. I should say, yes. Yeah, it would be m times right here. Okay, so next thing we want to do is, let's store our results in a set. Let's see, why are we doing a set? If we scroll back up here, it says return all the pairs of distinct indices. is highlighted and italicized. So distinct, it means you want to be unique and you want to be showing up once, right? So we want to store everything, all the possible palindromes we have, and sometimes you might get double, so we don't want that to be the case. So next thing we want to do is we have a list in reverse now, in the dictionary. Next thing we want to do is loop through it in the forward order. So we for I word and enumerate words. So notice how you're using the same function, same looping through here, same looping mechanism through in the beginning. It's not very efficient, but it's kind of a must in this this solution here. Let's see. We want to find, so for each word that we're looking for in terms of our the length of our word, and for each word in here, what we're gonna do is that we're gonna loop through for each element j in the range of our length of word I should say, plus 1. What we're going to do is that we're going to find a prefix and a suffix. So we're going to do prefix is equal to where assigned to let's see, so everything from the beginning of our word to j, and we're going to look for something called suffix, which is everything after j. So it'll be j colon. There you go. So we're able to loop through each of our words. For each word, we're able to find a prefix and our suffix that we're looking for. These are possible candidates that in order for us to make our list. So how do you know if our candidate fits our criteria in order to be added to our results? So for that, we want to look at 3 main conditions. So the first condition is we want to to see if a prefix is in our dictionary. We want to know, is this even possible to make our prefix from the words we have, right? That's the first one. If our prefix is in our dictionary, our next condition is and that has to be also satisfied, is that if our element I is not equal to our dictionary at the prefix location, right? Because we don't want the word to be already in our dictionary to begin with, because that's the actual word itself. And also the thing we want is we want to know that if our suffix is equal, it's a palindrome itself. Because we want to know if the word itself is a palindrome, then we're able to branch from that point and make add a prefix to the front of it as well. So if our suffix is a palindrome, then we are able to add a prefix to it. So we want to know if we want to know our suffix is a palindrome, this is how we do it. So we want to know if the reverse of the suffix is equal to the suffix itself. Okay, if that's the case, then we know our candidate prefix is good to go and add to our results. So results.add. So what we want to do is we want to add our pairing into there. So element I, we want to add their dictionary at the prefix. There you go. Okay, now we have our prefix solved. Let's do the same thing, a similar idea for our suffix. So if our suffix is in our dictionary, and we want, let's say, I to equal to the not equal to our dictionary at the suffix, I should say. And we also want to know if our prefix is itself a palindrome, and therefore we can branch from that point. It's equal to prefix. What we want to do is, this makes it a suitable suffix, a suitable candidate to be added to our list. Results.add. So remember, this is our suffix, so we want to add it from the reverse direction, right? We want to add it from reverse. So what we're going to do is dictionary at suffix, comma I. All right. What do you want to return now? So you want to return, scroll up, all the pairs of distinct indices in the given list. So in order to do that, we have every single result already. We have everything in a set. So in order to expand that out, let's do some list comprehension to be able to list all of our palindrome, let's say, characters for P in results. Alright, so now that we're turning that in a list, it's gonna be a pair listing within the list. Let's run the code and see how that works. Let's see. Alright, I forgot it's invalid syntax. What line is this? Oh, I forgot a comma right there. That's not it. Oh, I want it at the word location. My bad. Okay, finished, and it looks. So yeah, it looks the same. Just not the words, not the pairing are not in the same order. So let's submit to see if it works. Cross my fingers. Okay, accepted. Awesome. So in terms of time complexity, let's see what we're working with. So let's say if given our word length is n, and each element in our word length, so the length of each word is 300. So let's go over here. We do a for loop over here, which enumerates it. So this would be it would be n times, right? And we also do another for loop here for enumerating the word, so it would be n times. So it would be 2n, so 2 times n, right? Then we do a for loop again for a word length right here. So we have m now. So it'd be 2n, so for 2 times this, times our word length so far, m. And then we do a list comprehension to make a list of it as well. So we do another for loop right here, because the list is of constant time. So what we do is we do 2 for loops that are nested for this, for m, and we have 2 times the enumerate function for loop for our n function. So the overall time complexity would be a big O of n times m squared. And space complexity, what we're doing is we're keeping actually we're keeping a dictionary and a set, right? But the set is unique, so the dictionary will give us every single, so it would be basically we enumerate through, so it will be big O of n plus the set where we store everything inside as well, and also the list that we're returning. So yeah, I think it'll be a lot bigger than that. Probably big O of n times m. Alright, that's it. It's accepted. This is a night. I like this one. It's pretty deep thinking. Alright, have yourself a nice weekend or day.